button and we are going to get started. Good evening, everyone. Welcome to the Global Math Department. My name is Lee Natero, and I'll be your host tonight. Tonight, we're going to be hearing from Theresa Wills, and the topic is Rich Math Tasks and 5 Practices in Online Teaching. Would everyone please introduce themselves in the chat window, telling us what you teach, where you teach, and what your Twitter handle is, if you have one. I am glad to see so many familiar faces and some new friends here tonight. This is exciting. Before I introduce our speaker, let me explain about how these meetings work. These meetings are recorded and are available approximately 24 hours after the meeting ends. To view the recording, you would use the same URL you used to get here tonight. The global math community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. I'll catch your questions for the presenter, so don't worry that she won't hear them in the chatter. Tonight, our speaker is Theresa Wills. Theresa is an assistant professor of mathematics education leadership at George Mason University. Theresa has taught synchronous online classes and webinars for 10 years and researches teaching practices that are adaptable to the online environment. So you, as being an online teacher, if you're an online teacher right now, this presentation is going to be great for you. Prior to online teaching, they worked as a secondary math teacher, technology coach, and mathematics coach in grades K through 8. Theresa uses this background in teaching, coaching, and technology to teach rigorous, interactive, and engaging courses. And I'm going to now turn the presentation over to Theresa.
Hello, everyone. Good morning, good evening, good night, wherever you are. So glad you're here to join us. Yes, as Lee said, this is an example of my normal. This is how I teach class. This is how I teach class to in-service teachers, pre-service teachers, and elementary school students. I'm a frequent weekly volunteer in an elementary school, and I've even done synchronous online work with an entire 3rd grade class who decided to go paperless a year ago. So I have a lot of experience with lots of different ages and hoping to give you all some tips on my normal as things are becoming your new normal about how I use rich tasks and the 5 practices in online teaching. Our agenda today is to explore how to implement rich tasks and the 5 practices in online teaching. We're going to start off by identifying some hurdles, have some time to do the math, highlight advantages to online teaching, and let you know where you can go to get additional resources. I like to ground what I'm doing in a little bit of current research out from NCTM, the National Council of Teachers of Mathematics, on why on earth do we do these rich tasks. And so these are our 8 math teaching practices. You will see today a clear goal. There is going to be tasks that promote problem solving. We're going to connect using mathematical representations. The discourse is going to be the cornerstone of this. You will hear purposeful questions. You will base your solution on conceptual understanding. And I hope you're flexing those productive struggle muscles as we elicit and use evidence of student thinking. When I say the 5 practices, I know this has become kind of a lingo with math teachers. This is what I'm referencing. Smith and Stein's 5 practices for orchestrating productive mathematics discussions. In this publication, Smith and Stein talk about 5 very manageable steps to actually have a great math talk. And what I'm going to do today is build on these and talk about how I do them in the online environment. So let's talk hurdles, because whenever I tell people, hey, I teach online, usually the questions I get are, yeah, but how do students show you their representations? Or do you only get their final draft thinking? I want to see the rough draft. I want to see where they're starting from, what obstacles or misconceptions they have, and I want them to be able to communicate with each other. How do you do that online? So here's an example of a problem, and I'm going to give you all some time to solve this. It's about sharing M&Ms. And in this case, Janelle and her friends open a bag of M&Ms to share. Janelle says that she loves red and collects all the red M&Ms. She notices that she took 1/6 of the pack. Then Tammy collects her favorite M&Ms, green, and notices that she took 1/5 of what remained. Jenny collected 1/4 of the remaining package, all of the blue M&Ms. Samantha doesn't really like brown, but takes it anyways because it's 1/3 of what remained. There were two colors left, orange and yellow. The twins, Kat and Kelly, shared the remaining 4 M&Ms equally. How many M&Ms were originally in the package? I'm going to give you all a few minutes. You can feel free to start with the paper pencil version of this and jot down a couple ideas. And then in a few minutes, I'll move the slide forward and show you some virtual manipulatives that I usually send to my students when they solve this. But give yourself a minute and have that productive struggle time. You'll have a few more minutes to work on that. But in the chat box, I am putting the link to the Google Slides. And you're welcome to go in there. You'll notice there is that little green sound box up there, which links to Google Translate, and you can listen to this problem in English or your home language. And if you do go into that Google window on slide 7, you'll see that I have even listed several virtual manipulatives to use. Typically, when I give my students this problem, they get some time in small breakout rooms to work together. They all have a slide, and they're putting their responses to this slide, all their rough draft, raw thinking, all the misconceptions, all the ideas they're working on go on that slide. Every single student has a voice, and no student's work is hidden because it's all available up on the slide. Again, here's the link to the Google Slides. I'm going to keep the math problem up there, but using the link on slide 6, you'll be able to listen to it in English and your home language. You'll also be able to see the virtual manipulative selection on slide 7. All right, so we've had a few minutes to do this. I am not going to model how much time I would give my students to solve this problem, but seeing as many of you are math educators, I am going to kind of throw the torch at you saying this is a great one to solve. There's lots of different ways. Make sure you try different representations on your own paper and also using those virtual manipulatives. And then I'm going to show you a little bit of what happened when I did this task and the different models that the students developed and what you should expect. And while I'm doing this, I want us to remember those hurdles, the digital representations. How do I get my thinking up on the screen? The rough draft thinking. I don't necessarily want to see my students' answer of, let's say I see 12 a lot in here. I don't just want to see a number. How do I see all their thinking? And then there's that part of communication. So in the 5 practices, ahead of time, I've already anticipated. I've thought about all the different solutions I'm expecting students to get. And on top of that, I started thinking about what virtual manipulatives would I wish that my students had in solving this. I'll frequently give them some virtual manipulatives, much like you saw right here. There were 5 that I thought of ahead of time that might be really useful. But typically when I do this, I'll only give them 4 in a blank area for them to add a better one that they found, kind of putting that ownership and agency in the palm of their hands. All right, so I've already anticipated when my students are in small breakout rooms and they're writing on the slides, I'm monitoring, I'm listening, observing, figuring out what questions I need to ask them to get them to think about the math more. And then I'm going to be doing the same thing I would have done in a face-to-face class. I'm going to go around and I'm going to select which ones are the most important. Which ones are the most important to the topic that I'm talking about? And what order do I want to do those in? So what I've done here is I've given this problem some student work and a video with context about how the math talk actually unfolds. And when the video is playing, my task to everyone in the audience here is when you find instances where we went through these hurdles and you see some affordances of online teaching, to type those in the chat box. Alrighty, so here are a couple slides from actual student thinking. And it's just got some kind of raw, basic ideas down. Some people use text. Some people use tables. Some people copy and pasted those Unifix cubes. And there's a lot of just messiness on the slide. And I happen to embrace messiness because that's where I get to see all the rough draft thinking. All right, so here we are. This is the discussion in the video. I am going to go ahead and turn the video on here, and what you're going to look for is how is Math Talk working online? What are the affordances of online when we're doing Math Talk? Alrighty, so here is our video. Again, keep that chat box live and working. Read the problem-solving oath, and if you pledge this, go ahead and type your name in the chat box. This part doesn't have sound. It's just simply fast forwarding what students are doing right now as they are solving the problem, and you get to see all of the rough draft math that's happening.
So I started with 30 because I knew it was divisible by 6, and I got 5. You can see my guess and check table there. I knew it was too many, so I started with 18. And then I noticed that we had 3.
Quick,
so I
how
noticed
did you
this
know
pattern.
it didn't work out? I missed that part because it looks like you have done the fractions correctly.
Correct. The fractions worked out great because of the numbers, but I knew at the end those 3 people had 6 M&Ms left, and that didn't work out with my numbers that were left.
Oh, I see. And we had 15 there.
There instead.
Cool.
Yeah.
All right, keep going.
So then I knew that that was too big, so I went with a smaller number. So I started with 18, and I noticed the same pattern that no matter if I start with that number divisible by 6, that I still was getting the same amount for each person, and it was 3. And when I got to the last 3 people, there was 9, and again, I knew there was 6. So at that point, I didn't need to start with a number to guess and check. I knew that if each person the last 3 people had 2 and my pattern stayed the same, everyone should have 2. So then I just multiplied 2 times 6 and said there must have been 12 M&Ms to start.
So she started to see this pattern. And for everyone else who is listening, who can rephrase what was the pattern that she saw and how did that help her find the end number of M&Ms? Raha, go ahead.
So when she first started with her guess and check, she started with 30 M&Ms, and then as she noticed that the amount that each person was getting was 5, she noticed that she needed to lower her total number of M&Ms. That would lower the total number of M&Ms that people are getting in the story, because I'm sorry, at the end there were 4 left over and each twin got 2 and 2, so 5 and 3 wouldn't work, so she needed to keep lowering her total.
So this 2 and 2 is really important because it was the twins. Neat. All right, we're going to see how that compares to the green slide. If you all will come down to slide 34. This group did some really cool things, and what I want to focus on is this list. They have a lovely list here. And would you all take a peek at this list and a peek at slide 30 and tell us how are those two similar or different?
So I wanted to guess and check with starting with 24, and I noticed that in the previous slide, they also, like, there's a connection between 12 as being the total and 24 as being the total.
Well, to me, it looks like they both used a similar strategy and that they were guessing based on the quantities that were at the end. So they were using that end information, those numbers, the known quantities at the end, to guess the total. So a guess and check strategy again. So they were using similar strategies, I guess.
Neat. So there's this idea of this end number. So let's go to slide 30 real quick. Let's talk more about this end number. If Raha were to put her method, that was the one on slide 34, if she were to put her method on this table, what do you think would be those circled numbers at the end? And how do you know? If we were to make another table where 24 was the end number, what numbers would be inside these circles, and how do you know? Stephanie?
I think inside those circles would be 4 because she was starting with 24 M&Ms. That is 6 less than the 30 and 6 more than the 18. And so it's like 24 is equidistant between 18 and 30, and 4 is equidistant between 3 and 5. So I think it would be 4 for each if we put the 24 to start.
That's really cool. I like the way that you kind of found this midpoint between the yellow highlighted numbers and the circled numbers. Awesome. Let's head down to slide 32 real quick.
So I drew the 6 boxes that are at the bottom of the slide. And I did that because it says Janelle wanted a 6th of it. So I thought it'd be easy to kind of see a visual. And so in the first box, I put Janelle, but she took a 6th of it. And then it says Tammy collects a 5th of it. And so I notice I have 5 more boxes. And so a 5th of that would be one of the boxes. And so that leaves me with 4 more boxes.
Hold on
and it
1
says
minute.
Jenny,
I think you
ahead.
just said
Yep.
that Tammy took 1/5, but she has the same amount as Janelle. Can you explain that real quick?
So she took 1/5 of what was remaining. And so she didn't take 1/5 of the whole, which is different.
Awesome. All right, keep on going.
Okay. And then Jenny did the same thing. She ignored what Tammy did. And so there's only 4 basically rectangles left, and that's the whole now. And so she took a 4th of that. And then there are 3 rectangles left, which are then the whole, and Samantha took a 1/3 of that. And then there are 2 rectangles left, and that's now the whole, and it says the twins shared the 4 MMs equally, so I put 2 here and 2 here for each of the twins. And so to me that tells me each rectangle equals 2. So then I went back and I said, well, then Samantha has 2, and Jenny has 2, and Tammy has 2, and Janelle has 2, and if I add all those up, I get 12.
So that's kind of interesting about fractions, is Janelle had 1/6, but as soon as we took Janelle away, our fraction wasn't 6ths anymore. And now we're looking at it in terms of 5ths. And we could take Tammy's away, and then we would have 4ths and so on. There's another group who did something similar to this, and I want us to compare the two. So on slide 33, and I know you guys have 2 representations here, but I'd like for you to talk about the one with the arrow.
If there were 6 pieces, or, because I didn't know each one represented 2, I was like, well, let's just write one, make it easy. Looking at that denominator of a 6, then Janelle ate that 6, so then there's 5 left. So it's very similar. Tammy ate the 1, now there's 4 left. Jenny ate a 1/4 of what was left.
What is similar and what is different between slide 33 and slide 32?
In slide 33, they're representing the whole using pieces. And in slide 32, they're representing the whole as a linear model, but either way, part of each whole is represented with either a unifix cube or a box.
In slide 33, we have 2 yellows, but what does that number actually represent?
4.
So that's actually 4 M&Ms, even though it's
Right.
2 yellows. And so another neat thing that this group did over on the other side is they tried to be a little bit more concrete.
So we started down here with what was left. So we knew there were 4 left, and that now I forget who took the brown. Samantha took 1/3 of what was left. So from the brown down, that's, if you think of that as the first whole, Samantha had taken this 1/3. So this represents 2/3 of what's left. So we knew that was 4. So 4 was 2/3 of what was left before Samantha took hers. So we knew that, these brown, orange, and yellows equaled 6. And here's 4. So the browns were 2. And then we kind of just worked from there.
All right, folks. So that was just a little video of what happens when we do these math talks in the virtual space. And thank you to everyone who continued to write questions and ways that they saw us overcoming these hurdles in the video. There are a couple of things going on here. The audience that you were just listening to are indeed teachers. I have plenty of video of 3rd graders doing it, but right now got to get through all that red tape before I put video like that online. So I have videos of teachers, and quite frankly, my 3rd graders are way more interested in sharing their ideas out without really caring if they're right or wrong. They're just ready to go. I have a lot of experience also in community building, so I wanted to kind of touch base on that here. If you talk to anyone who is a big video gamer, they will tell you about their best friends online. I used to be one of them. When my best friend got married, actually, she invited 2 people from her guild to her wedding that she never met face to face. And she only had a 50-person wedding. So that's a big ratio if you think about it. So we can build these communities. And part of that is when students are working in small groups to try to overcome this math challenge, this productive struggle in math. They put all their rough draft thinking out there online, and they're working through it. Students will sometimes write mostly in the chat box or write on the slide. Others will talk a whole lot. And there's, again, classroom management and norms that you can set in terms of equitable talk time. I hope some of the things that you saw in this were, first of all, the digital representation. There was a lot of, it could be virtual manipulatives. It could be just the shapes within Google, tables, text boxes, circles, and arrows. But a lot of this was done during the math talk. Another thing that happens during the math talk is a student might be listening and engaged, and all of a sudden wanting to go down some other math avenue. They will simply duplicate the slide and start editing right on top of it. And that's one of the affordances that I found online that we couldn't get with a poster hung up in the room, is that I couldn't just grab somebody else's work and start circling the fifths and circling the fourths and really making sense of it to me. Alrighty. At the beginning, I mentioned I was going to be talking about the 5 practices and these 3 hurdles. One thing that completely changed my mindset, and I encourage you to look into if you haven't heard of this yet, is the SAMR model. The SAMR model is the way that I started framing, turning my face-to-face class into an online class. So for example, I did not want to compromise manipulatives. That was a game changer for me. I wouldn't do it online if I couldn't use manipulatives. And so I found a way to substitute with the virtual manipulatives. And as we continue to frame our mind into what are the affordances of online, as opposed to how do I do exactly what I was doing, I started to realize that when students are editing each other's work while the conversation is happening, that is just something that I couldn't get in the face-to-face. So I really started to think about how can we modify or redefine these tasks so that it is different. And much like teaching adults, I am not going to teach you with the same pedagogy as I would children. The same thing goes for online. I'm not going to use the same pedagogical moves for online, but they might have very many similarities. And so I put this slide up because I think a lot of people are talking about this in their school. What kind of mindset do you have when it comes to online learning? Is it a growth mindset where you start to wonder, well, I'm not able to do what I did before, but maybe I can do something different or better? Or do we have the fixed mindset of, I can't do this online? And so for me, I use the SAMR model to think about how I can change things to make it better than online. And that led me back to the 5 practices. Smith and Stein talk about anticipating, monitoring, selecting, sequencing, and connecting. And this has long been my 5 commandments of math teaching for years. And I got to be a pro at it in face-to-face class. But then when you move it online, what's different? So I have these yellow boxes, which I would add to the 5 practices. When you're anticipating, you also need to think about how students are going to put those digital representations on their screen. You need to think about the virtual manipulatives, the low-tech stuff, like taking a picture of your notes, to the high-tech stuff of virtual manipulatives that are moving as we're talking. In the monitoring stage, as the instructor, I can view the entire class's work as they're working on it. I can see all the little slides on the side and move up and down, and that saves me time. I'm not literally walking from one set of students to another. Instead, I'm glancing at the slides, and when I see what I want to see or something that totally perplexes me, I'll go into that room and I'll talk to the students a little bit more. The selecting stage, a lot of these students knew that I was going to be talking about their representation because I put an arrow on it at the beginning. And so I've got this little trick that helps them to know what I'm selecting and me to remember what I'm selecting. A nice thing about slides is the ability to duplicate them. So when it comes to sequencing, I just duplicate all the ones I want to talk about, move them down, and we move between those. And then finally, connecting. I've learned that there are some affordances to online learning that I just can't get in a face-to-face classroom, and that's what I'm calling dynamic math talk, where during the conversation, we are circling big things. Other students are circling them. Another student who never talks in my class all of a sudden is the one putting the arrows and the annotations that in each of these we're doing a +2. And so it's not just the student presenting, and it's not just the teacher who's writing on the slide and making the connections. It is anyone who has access to those slides and are there in that class. I have a couple tools for you to be thinking about as you are enacting some of these rich tasks online. And the first one I typically get are, what if my students don't know how to use the Google? And so I would usually respond with, in my first class of any age, even my little kindergarten, first grade Girl Scout daisies that I'm a troop leader for, they get this. They're very young. I tell their parents, don't click anything, just see what they can do on their own. And they do a couple of them. We've got 3rd graders who could do all of this in 20 minutes, no problem. We've got others who could only do 1 or 2, and that's fine. It's my pre-assessment of the competencies I wanted them to have. So do you know how to copy and paste slides? Do you know how to upload images from your cell phone? Do you know how to make irregular polygons? Because this was a geometry class, and that was important to me. And what you're seeing now is results from a variety of students who had a growing problem task, growing patterns. And some of these are from all different age students. And you'll be able to see how some of them just take a picture. Some of them are comfortable trying out virtual manipulatives. Some of them are making a really wild table. And some of them are using Google to actually figure out, in this case, it was how old is this worm, and they find out how old worms live. So there's a variety of ways that we can get representations. It's not just paper pencil, but I don't say that you can't use paper pencil. If people want to put that on, you know, definitely go for it. It gives us stuff to think about. I saw so many questions that I definitely want to get to, but I will mention that if you want any of the templates that you've seen, I have them all available on my website. I want to end with enough time to be able to answer those questions that were coming in. So before you log off, let me remind you that some of us have been doing this for years. It's our normal, but it doesn't mean it's not accessible to you. Take one idea, give it a try, see the way different people are using it, and you know, give students that chance to show you what they know online. So I did notice a couple questions in there. What platform do I use? I've used Blackboard Collaborate mostly just because my university uses that and the school system I was working in uses that. Zoom does the same breakout rooms. I've also worked with several administrators about lessening the restrictions on breakout rooms. One thing that I've noticed is that with the proper classroom management and accountability, much like a regular face-to-face class, you can have very manageable breakout rooms.
Theresa, I did
Yeah.
just share a link in your private chat there to the document where I posted all the questions that were, because there was like about 15 of them or so that appeared in the chat. So if you want to hop on that, you can kind of see the questions that are there. So some of them are related to forming groups. Some of them are related to, you know, what system you're using. Some of them are related to what age students you would do this with. So I don't know if you can see the questions in that document I shared with you.
I don't see a document. Hang on. But Lee, if you wanted to read the questions out to me, I can answer them. I don't see the document though.
Okay. I had put it in the private chat tab for you.
Okay.
But,
yes, here it is.
do you see it now?
Yep, I see it. What platform do you use? And I'll typically always use Google Slides. The affordances of Google Slides is that if I give students access to edit, they're going to be able to edit. They're going to be able to add their thinking to the slides, and I'll be able to see it as it happens. People are asking, what curriculum do you use for middle school? I work with teachers who use a variety of curriculums. I usually try to work with teachers who do inquiry-based math, and so it's all about problem solving and finding these rich tasks. What if students cannot meet in real time online? This isn't my specialty. I work completely with real time, but there has been a wave of teachers talking about how to use some of the interactive templates and giving them to students ahead of time so that they can start to write in the slides. And when the live session happens, there's already parts done from other students. Someone asked about students with disabilities. There's a variety of things that I try to do in my online, including whenever there's a problem, it gets linked into Google Translate so that it can read it out loud in English and a home language. And much like other differentiation, if I needed to, let's say, break up the problem into smaller components, not taking away the richness of the task, but breaking it into smaller components. There could be different slides there. I might have purposeful breakout rooms with co-teachers in those rooms, etc. Those are some of the things that I would have done in the online environment. Do you ever have students reluctant to talk? Absolutely. And I do the same thing I do in my face-to-face classes. During the selecting and sequencing stages, I go through and I let them know, I'm going to come to your slide and I want your group to talk about this section here. Who in this group feels comfortable talking about it? I might get 2 hands raised out of 4. Great. Make sure you chat with the other 2 folks, and I want one of them to present. Maybe I don't do it the very first class, but I would have done the same thing in the face-to-face where they are building that small community together. Also, I use the chat box a lot. If students are reluctant to talk over the microphone, it's just a matter of time. But in the meantime, they get to talk over the chat and they get to do what they feel comfortable with. Once their confidence is up, my students have no problem talking on the microphone. Even those introverts really enjoy it too. How do you hold students accountable for typing or talking? Sometimes I will give them very specific roles for the chat box. Much like when you all were watching the video, I asked you, when do we come across these 3 hurdles? That was your question to be typing in the chat box. I'll do the same thing with students. So in the problem that we did, I might ask, let me know when you see an example of 2 M&Ms. So somebody's talking about the M&M problem over the audio, and students are typing in, oh, I see 2 M&Ms in 1 yellow Unifix cube, or I see 2 M&Ms in the last box, or I see 2 M&Ms at the bottom of the first table. So they have a very purposeful thing for that chat box, and others are still talking. How do groups talk to each other while they are collaborating? They have mics the same way. When they're in their breakout rooms, I typically say, once you're in there, all mics on, unless a dog's barking or you have something else in the background noise, then only turn on your mic when you are talking. But when all mics are on, you're hearing those informal conversations of, oh, I think I got it. It's 24. Oh, wait, no, 24 won't work. Why is it? It must be 12. And so it's those little kind of conversations that we do want to capture. There were a couple other questions on asynchronous. Again, asynchronous isn't my specialty. There are some incredible experts out there, but I do know the power of editable Google Slides, and giving students a chance to either type in them ahead of time or afterwards is a great way of including them in the live session that they weren't able to make. Let's see. Someone asked, have you found assigning group roles to be helpful? Absolutely, especially when I started with the 3rd graders, getting them in. We had one person who was in charge of finding pictures to put on the slide, another person in charge of text boxes, and another person in charge of, let's say, the timer. And so giving them those specific roles gave them a chance to kind of own a job and, again, bring in that classroom management. Someone asked, is 3rd grade the youngest grade that you would do this with? And I have done this over a year with 3rd graders, just because that was a project that I happened to be doing. However, I mentioned earlier, I'm a Girl Scout leader and I have 14 daisies. There are 6 of them in kindergarten and the rest are in 1st grade. We started off this time mid-March on Flipgrid, just doing videos back and forth until I realized that they had that under their belt. And then we started Google Slides. I can give you a couple examples of what I did with the young students. A lot of things were, how are you feeling today? And they were able to give an emotional response. And I've got a PD that I actually do that talks more about the younger kids. Let me see if I can get that slide up real fast here. All right, I'm going to bring it on over to this slide. This is a PD that I do specifically on littles. And I think you can see, yeah. So you can see here that the kids can, their profiles are already on here and they're moving how they feel that day down to their picture. And this is a great way to get them just used to how do I use Google Slides before we even get to the math. We teach little kids how to undo things. So we do a whole lesson on the power of Control Z. And Control Z is actually like our hero because they don't get mad at you when you make mistakes. And they actually practice making mistakes. They practice like deleting somebody's work and then hitting Control Z and bringing it back on there. And so this is a group of kindergartners and first graders learning how to be digital citizens online and how to work in this interactive environment. Again, if you're interested in that, that's on my website also. Let's see. Someone asked, how do you see all the student work at once? It's through Google Slides, and it happens just as they're developing it, it all pops up on the screen. Someone asked, how do you divide students into small groups? And I'll go back to, again, what I would do in a face-to-face classroom. Typically, I liked groups of 4. I just had a personal preference to that. And so I would split students up into groups of 4. Depending on the platform you use, I know both Zoom and Blackboard Collaborate allow you to do it randomly. Sometimes I'll have student names on a slide and they move themselves into the breakout room, and that way I can kind of make sure certain students stick together. And I can always move students in and out. So the same freedoms that I had in the classroom, I'll do online. And that also goes for pedagogies such as pair share. Some of you have been trying synchronous online and probably noticed that when you say, does anyone have a question? It's silent. There's not a hand raised, there's not a voice. And so what I would do in a face-to-face classroom, if it was either silent or everybody showed me that their hand was up, they did a pair share. So I made random groups of 2. They're in their breakout room with their partner. They can't hide because it's just the 2 of them, and they're talking that question over. I bring them back to the main room, and then they are able to share their answers that they talked to in a environment where they already had a chance to discuss it. Someone asked about Pear Deck. I don't have a lot of experience with it because as a general rule, I use things that are free. I'm also working on an equity standpoint where Google Slides and Zoom and Collaborate can all be done on a Chromebook, which is really important to me because it's one of the cheapest devices that you can buy, and you don't need to upload other programs and you don't need to pay for anything. So that's where my specialty lies, but I've heard great things about Pear Deck. Someone else asked, how do you divide students into small groups? I do a variety of things that I would have done in a face-to-face class. Sometimes there are people who are better at making pictorial representations, and sometimes I want them all together. Sometimes I want them dispersed. There are some kiddos who are really fast with mental math, but maybe need more support in drawing it out or explaining their reasoning. Sometimes I put them all together. Sometimes I spread them out. Sometimes I'll do the same with behaviors, like if they're really big talkers, great extroverts with a lot to say, sometimes I put them all together, again, because that helps them to practice equitable talk time. And other times I'll split them up because, you know, we need some of those folks in every group. So how do I divide? Always purposefully, but for a variety of reasons. And then someone else asked about assessment platforms. Most of the time when I do assessments, it is take home and they they do their assessment in Google Slides. So they're practicing all those same uploading of representations. It's just, one question per slide. And so they just upload them into the Google Slides. And someone said, what if you don't have breakout rooms? There is sometimes what I would do is give students the task ahead of time and say, like, email me all of your different ways of thinking about it. And then let me see if I can grab a quick example. I'll put all of those representations up on the slides, and I'll have the students as a whole kind of talk about what does this representation mean and why. So they would have done the representations up front. Here we go. Here's an example from another PD. This is that growing worm again. You can see that there's a variety of representations already here, and we would just jump into the math talk during the synchronous time. One of the downsides to that is they don't always get to work together on the representations as they would in a synchronous environment, but it still lends to the math talk. I think I got to most of those questions. I encourage you to continue to share your successes over Twitter also. I love hearing about how people are implementing these different practices. And Lee, if there are no further questions, I will have it take it over to you.
I think there are some people that are typing questions actually in the Q&A area.
Got it.
And so if you click on that, you might be able to see those.
Yes, here they come.
That are there at the bottom that were typed within the past minute.
Yes. Okay, so the question is, could students look at what other kids are doing on the slides? Yes, they absolutely can. So let me see. Let me get out of the presentation mode. I typically do my class like this, where I can see all the slides on the side, and we have one here. If I'm in the yellow group, we're working here, but I can see what the other students are doing on the other slides. Now, there are ways you can make it happen so that that is not the case. You can give everyone their own Google link, but I've learned to love that they can see what's on other people's slides, because they can at any time say, all right, I'm stuck. I need some ideas. And they'll move down to green and say, ooh, they're using circles. Let's use circles. Let's see how that would look like. So they'll type that in here. They'll start to think about it, and they'll add on to it. And the norm in my class is you're allowed to copy and paste stuff from any other group, give them a little shout out at the speaker notes at the bottom, and then add to it, make it your own. So you might say, like, we found the circles from group 4, and then they copy and pasted that a bunch of times to make it their own. Class size, I've used Google Slides anywhere up to 75 students at once. If you're going to have more than 75, you probably want to make 2 duplicate sets of slides. Google gets really slow and clunky. They say they go up to 125. I find about 75 students at a time is it keeps the flow still working. Would this one math problem take up the whole lesson time? Absolutely. I do a rich task for 1 hour. Sometimes I'll do a launch ahead of time where the students will do, let's see if I have the other activity up. We'll do something like a number talk ahead of time, and then we launch right into the task. They get 15 minutes to work on it in small groups while I monitor, and we spend a good 20 minutes debriefing it and talking as a whole group.
I see one more question in the main chat area from Bina.
Let's see, in the main chat.
I mean, this is maybe for somebody else that was in the chat, but I mean, you have your students all working together in the same area, I guess.
Yes.
That was directed to somebody else.
If you're looking for other math problems, I am continually updating my website with more math problems. offering more chances for math teachers to just interact with the problems too. So you're welcome to head there. Everything I have up there is free for non-commercial. So if you find a task you like or a student work example that you want to incorporate, go for it. All the slides are there, and they're all able to be copied and put into your own class.
Theresa, I have one question for you. I noticed that you had a YouTube channel listed there. Can you describe what's on your YouTube channel in general?
Sure. Let me go ahead and pull it up. So I'm trying to work on getting videos out, even though they're not perfect, but getting them out of activities you can do in your class. So recently, I've been doing some brief number talks, or which one doesn't belong, or choral counting, or proportional reasoning, little routines. And I've got some of those little videos in here where they will talk about, in this particular one, we were looking at the proportion of Charmander to Charizard. And then the activity was go out and find your own Pokemon and see if you can use the heights to figure out how they should look and be in proportion to each other. There's other full recordings. So I do a lot of free professional development right now, again, through my website. And I do the full 1 hour long recordings. So you can see like the Pokemon task was at the very beginning. And then this is the one for the M&M. So you can see the full recording of all the buts and and that's all available there as well. So anything from small routines, tips about classroom management, clips about how to share Google Slides, using Math Talk, and my kids put one up of some dogs, but mostly math stuff, the which one doesn't belong strategy. So that's what's available on there. Again, I've been doing this for a while, so I realized that I needed to post it online for other people to see.
This is wonderful. Thank you so much, Theresa. I feel like we are really, really fortunate to have the wealth of resources that you've shared with us tonight. If you have any questions for Theresa, I would encourage you to send her an email. She is on Twitter. And next week, we have Making Math Teaching Visible, Embracing Ed Tech to Help Students Demonstrate Understandings for grades K to 12. And we'll be talking about things including Pear Deck, Flipgrid, and Satori. And our presenter next week is Stacy Roshan. Thanks to everyone who joined us tonight, and feel free to rewatch this video once it is posted in about 24 hours. Thanks. Good night, everyone.
Thanks, Lee. Thanks, everyone. Happy online learning.